So here in example 2, let's find the p-value, observed significance level for example 1, find it directly, and then we'll check with the calculator stat functions. So our test statistic, remember, here was negative 1.167. That was down here on the left. And this was a lower tail test, so the p-value is the area past the test statistic right there. And that's going to be the probability that z is less than negative 1.167. So we can use normal CDF here because this is a normal distribution, approximately normal. And then let's see, lower cutoff, negative 10,000. Upper cutoff, bring this down, give myself a little more room. Was the negative 1.167. Mean and standard deviation 0 and 1 because we are using z-scores. So let's compute that. So go to second variables, normal CDF number 2, negative 10,000 to our upper negative 1.167, mean standard deviation 0, 1, paste it, 0.1216. Test result, our p-value, which is 0.1216, is greater than 0.05, which is our alpha, so we do not reject H0. And then the interpretation is going to be the same as it was here. There is not sufficient evidence to conclude p is less than 0.056. New screens are not better. So interpretation's the same, but it's a p-value test. And then let's use one prop z-test here to verify things on the calculator. So go ahead and clear this out. So I'm going to go to stat, tests, and then I want one prop z-test, one proportion z-test, so that's number 5. Our hypothesized proportion was 0.056. Our successes were 22. Our sample size 500. And then this was a less than p0 test, so we're good there. And calculate. And there's our sample proportion, 0.044, our p-value, 1216, and then our test statistic, negative 1.167. So, and then if you do the draw, it'll actually draw your p-value. So if we go to stat, test, 5, and then come down to draw, then that area, test statistic right here at negative 1.167, and that blue area is our p-value 1216. So you can always check yourself.